Hello everyone, Storm101 here. Today we'll be having an update on the potential for a blizzard that could develop across portions of the Ohio Valley into portions of the Great Lakes. Now, hopefully you guys yesterday had a really good Thanksgiving. Uh, Something I'm thankful of is you guys subscribing to my channel and also, viewing some of my videos, commenting, liking the video. I really do appreciate it. Also want to appreciate you guys as a very thankful of that have recently hit 400 subscribers. I may try to do something with that, maybe do a little special live stream or something like that for a celebration. So I'll be thinking about that um, as well there as well. So hopefully everybody else had a great Thanksgiving. I know I had as well. So let's go ahead and get into the weather side of things here. So we got a new model in here, and that's the NAM. Now it does not go through the entire event, but this kind of gives us an idea early on. And let me tell you guys this first of all. This is something I'm starting to see with some models here. The models are having a hard time with the transition over to snow. You can see here at this point here, there's a pretty big gap of rain here in between some snow. And this can really be a big effect on your snowfall totals that the models are actually spinning out. And this is something mentioned on Twitter last night here, is some of these models are actually having a hard time with the transition over to snow here. And then you can see here, it's kind of happens again here across some of these regions here. And this could really put out some inaccurate snowfall totals, which they already are. But some of these models here could be putting out some inaccurate snowfall totals here as well. Pretty much nearly every single model I've looked into has the same issue here. But there's one model in particular out there that I think it has a better handle with the transition here. But then, as you can see here, you got a pretty hefty amount of snow across really all of Indiana to southern Michigan, central western Kentucky, into western Tennessee there as well. And you can see here with that large snow band here. If this verifies here, we can see quite a bit of snow. And again, it does not go through the entire event. But this is the snowfall mass that the model was kind of putting out here. You can see here showing snowfall mass. Some areas could be approaching 8 inches of snow. Now and again, with the models having a little bit of trouble with the transition over to snow, you can see how kind of spotty it is. Like right in here, there's a cutoff right in here. You can see there's 5.3 inches here and also 5 inches here. And there's a cutoff here because it's having a hard time with the transition. To be realistic here, this region here, we're probably seeing 5 inches of snow. And also, kind of similar situation here, there's a little bit of a cutoff right in here. And you can see some little spotties here. So, snowfall amounts may be a little bit higher than what the models are actually spinning out. That's kind of the point there. So, that's just something I want to say there. But you can see here, the name is putting out some pretty good news for snow lovers across various regions here. I can see a decent amount of snow here as well. Let's look into the Euro. I mentioned this on Twitter last night. It is quite depressing. But let me show you guys the precipitation type first. So, here comes your system here. 1005 millibar low. Number one is that it's probably a little bit further to the west than what some of the other models are showing. Number two is, again, having a hard time with that transition over to snow. I mean, look at this gap right here. That probably snow for realism here. Likely these regions here will be experiencing some snow. Go to the next frame. Man, it's already up into Virginia in just 2 hours. Actually, more than 2 hours there. Actually, there's, well, about 12 hours there. It's already up into around Virginia here. Now, one thing to note is that of how progressive it is. It's the progression. Now, the recent GFS is also showing something very similar to this, which I'll show you guys that in just a moment. and but also again having a hard time with the transition over to snow. Actually, hard time seeing the snow. I mean, you can see here it's kind of all over the place in the winter side of things there of the system there, and then it starts to go there as well. Another thing to notice is here is there's going to be a decent amount of lake effects, so potentially coming off from Lake Michigan for areas across northwestern Indiana. So for some of these regions here that get, you know, the big winter storm here, adding on top of that lake effect snow, you guys could be in a bullseye for seeing quite a bit of snow there as well. So that's just something I want to mention there as well. And yes, let's take a look to the snowfall accumulations. Now, this is not good news here for snow lovers, just to say the least. That's it. That's it. You can see generally for Kentucky, 1 to 2 inches in general. Even the same thing across southeastern Ohio as well, 1 to 2 inches. Not a lot of snow. But if you go to south central Indiana, you can see there's a pretty decent swath of up to 8 inches of snow. And there's a couple areas seeing up to a foot of snow across kind of along the lake region of Lake Erie there. But some of that is contributed by lake effect snow. Just to keep in mind that you can see a little bit of a stripe right here. That's likely going to be some lake effect snow there as well. So not all of this is from the system. Some of it's actually coming from lake effect. That's the same way up here. Some of this is coming from lake effect snow, which the European model is probably underdoing those snowfall amounts up there, to say the least. There as well. Look at the mountains though, you can see a decent amount of snow there as well. Generally 3 to 6 inches of snow in the mountain regions there as well. So now the reason why for such low snowfall amounts is how progressive the European model is, which I'll probably show you guys that in just a moment. I don't think I have it in here. Yeah, I do. Alright, so let me do this real quick. Let me show you guys something really quick here. So we're going to zoom out uh, to the continental United States here. Now, let me show you guys the reasoning why there was a cutoff low in the first place. Now, first of all, our system is really starting to really take shape here across the Tennessee Valley, but at the same time, look at this ridge here. That's a very, very positive PNA there, and that will bring in some well above average temperatures across the northern plains back into the northwest. Now, this is quite unusual here to see this because this is an El Nino type of pattern, and we're currently in a La Nina. But look at this system here. Really started to take shape. It just gained strength there. And now we got ridging pretty much all across the really Canada. I mean, just look at that. Ridging all across Canada here. And one thing's for certain is here, this system here actually had an opportunity to get through the ridges there in time. That's why it's being so progressive, because it had the opportunity to go through there, but then the ridges blocked that low pressure system out. It actually made it out of the way. And now we got very strong ridge across Canada. And this could be the similar situation happening to this system right there, which will be for a different video. But that's what happened in the first place there for the cutoff flow, because there was ridging all over Canada. And this is sticking around across portions of the Ohio Valley till there's a weaker area of that ridge. You can see here at this point here, your low pressure system could likely just get ejected to the northeast. So that's definitely we gotta watch for is the timing of the high pressure system. The two high pressure systems conjoining into one there as well. So that's something we gotta keep an eye on there as well. Now, before we kind of get into some of the other models, let's take a look to the wind gusts. Now, the blizzard potential is still there. And I'm also backed off with the winds, which I'm not surprised. You can see here down into Monday here. You see European models spinning out wind gusts just about around near territory, blizzard territory, in a few areas here and there as well. You can see around the same time there is some snow falling there as well. So the blizzard potential is there. It's just it's lower than what we said before on the last video. There's well. So keep in mind the blizzard potential is still around here. It's just the chances have gone down a little bit. So yeah, and on that, let's take a look to the GFS. Like I said, pretty much the same way for the European model, being very progressive. But also to notice, it's probably the worst that I've seen having a hard time with the transition over to snow. Just look at this. It's missed a very large portion right here that's probably seeing snow at this point. If this area is seeing snow, then likely a lot of these areas here are probably experiencing snow. And look at this next frame here. This region right here, likely probably seeing snow for realism. Same thing right in here. This is what I mean by models having a hard time with the transition because the cold air is going to be moving in very quickly here. So this is definitely something we're going to be watching here very closely there. And for models that have a hard time with making that transition over to snow, it's going to push out some inaccurate snowfall totals. See if this here will load. But I'll say that the snowfall totals are quite similar to the European model. Well, not quite actually. It is similar across Kentucky with a general 1 to 2 inches of snow, but it's also spitting out some of the highest amounts across northern Ohio, which is something that's going to contribute by some lake effect snow, just to keep in mind of that. You can also know some could be a decent amount of lake effect snow from Lake Michigan there as well for northwestern Indiana. There's well up to 4 inches of snow there as well. So this is definitely something we're going to be watching here, and this is making forecasting quite difficult here because the models are now having a large spread of where some of the highest snowfall totals are going to be. So that's going to make forecasting quite difficult there as well. Let's move on to the Canadian model, which I think it's now this is the model I'm going to be following here because of two reasons. Number one is it's it does a better job than a lot of the other models with the transition. It still has a little hard time, but it's better than the other models. Second of all, it has been very consistent for the past several days with this. That's two things there. And this is the 12Z run of the Canadian. You can see it has a little hard time with the transition already. I mean, this area here probably experiencing some snow, but it does a little bit better job with the transition over to snow. Also to keep in mind is it's a little bit slower. It's a little bit slower, but I think it's a little bit more accurate here. And also I think has a little bit better handle with this as well. And if I show you guys the snowfall amounts for the Canadian, you can see here this is similar, a little bit similar to what I could be thinking of for snowfall wise. Not my official snowfall forecast, but this is something a little bit similar that I'm thinking about here. I mean, the Canadian model is does a little better job of the transition. Plus, it's also been very consistent with this solution. So we may have to follow the Canadian solution because, first of all, it's been very consistent. And that's probably everyone's number one reason because it's been very consistent than the rest of the models. Now, we're going to see if the NAM could be staying consistent as the Canadian because the NAM is a little bit similar to what the Canadian is spinning out. So, and I think the Canadian is probably going to be a little bit more accurate with this here, especially for snowfall totals as well. This is similar to what I could be thinking here as well. So we'll see if the Canadian model will change on the 0Z run, which is tonight. That's a pretty fresh one. Run there as well. Yeah, the European model will be updating this afternoon. I'll post it on Twitter. If you guys want to follow me on Twitter, it's at TyStorm101. I'll write it down, put it in the description down below there as well, so you guys can write it in or type it down as well. You guys can follow me on Twitter there. I'm usually more active over there. Now I'm on here. So last thing is the GFS ensembles. Now this is all 20 members on an average. You can see here showing some of the higher amounts across cut around Lake Erie. But again, some of these are really lake effect snow as well. Lake effect snow will try to get, try to get mixed in with this potential winter storm as well. But you can also see here showing a little bit better confidence here of showing a little bit higher snowfall amounts across Kentucky than some of the other models in general, especially for showing higher amounts than the European model in this GFS. We'll see if the European model will change in the next round. We'll see if it kind of goes back towards a Canadian solution because those two models really have been, agreeing on each other for like the past few runs. Well, not the past few runs. Well, they've been, agreeing on the storm system for a few runs and then they kind of split off there as well. So we'll see if they'll agree again here as well. So, but here's the GFS ensembles. You can see here showing some of the better chances for some higher snowfall accumulations, more of across northern Ohio, northwest of Pennsylvania, into far southwestern New York State there as well. Now, this is the probability of seeing some snowfall accumulations, just to keep in mind that. So areas in the blue, which even includes the mountains across North Carolina, in Tennessee, and also across West Virginia. Even another area across a good chunk of Kentucky, southeastern Indiana into most of Ohio, in southeastern Michigan as well. Those are areas that can see the bet the better chance of seeing snowfall accumulations, which includes places like Indianapolis, Cincinnati, Louisville, Lexington, Columbus, just about in Fort Wayne, Cleveland, Toledo, Ann Arbor, and also Detroit as well. Those are areas that have the highest potential to see snowfall accumulations, which I should probably expand it to up into southwestern New York State as well. I probably should expand it up there as well. Areas in the white and in the light blue. You got still have the possibility of seeing some snowfall accumulations. Just to keep in mind of that, it's just a chance we just have lower confidence with snowfall accumulations across the various regions here as well. So just to keep in mind of that as well. So that's my little forecast there. Now, not only this storm system will bring near blizzard conditions and also decent about snow on the winter side of things, let's move on to the warm sector. This is day 3 of the SPC Severe Weather Outlook. We got a margin of risk for severe weather across southeastern Louisiana, southern Mississippi, Alabama, the Panhandle, Florida, central and southern Georgia, most most of South Carolina, and eventually getting to southern North Carolina there as well. Pretty much all the threats are on the table. Maybe not so much for hail, but the primary threats are going to be damage to winds and possibly an isolated tornado as well. That's the threats we're looking at right now. Now we are lacking on some instability here, but some of the other agreements are actually in place here for the possibility for some severe weather. So let's take a look to surface space CAPE with using the NAM here. You can see here we got a decent amount of CAPE here. So this is Monday here, and today is Friday. Um, yeah, if I'm correct here, I believe Sunday is day 3. Yes, so this is day 3. Kind of off the screen here, you can see there's some instability values back down into Mississippi. Try to get along the coast of the Carolinas there as well. Same thing for Georgia. Some potential there for some severe weather across those regions, but I think the better chance is going to be Monday here. And as you can see here, we actually got some higher instability values here as well. It's also a little bit more widespread. And you can see it really starts to spread up into Virginia there as well for some of these surface-based values here. But let's look into the mid-levels. That's kind of the key thing for some severe weather is you gotta have a decent amount of mid-level instability. And that's something we're seeing right here. Generally over 1,000 CAPE here or 500 CAPE, you got a chance for some severe weather. And that's what we're seeing right in here. Now, there's going to be plenty of moisture in there as well. We'll also take a look to some of the 5-hour build bar wind speeds there as well. We'll take a look at that in just a moment. This is the Super Silk composite. You can see here, we got some decent numbers here. We got a number high as a 7 there. Now, the NAM typically overdoes, some severe weather events here. I've seen it happen multiple times, especially for the Super Silk composite. It usually overdoes some of the stuff here. But if the NAM is correct here, yes, the environment will be favorable for at least a few tornadoes. See, we got a pretty decent holograph there, got a good amount of wind shear here as well, and also a decent amount of cape there as well. You can see how it kind of spreads up to around Norfolk into Virginia Beach as well. We'll try to get another sounding here, and pretty similar here as well. So generally, the environment can be favorable for some severe weather. Really anywhere from the southeastern Georgia coast into the Carolinas and into Virginia, possibly as far north as portions of Maryland and Delaware there as well. You can see if we go towards the end of the run, it even expands up into New Jersey, eastern Pennsylvania, even as far north as southern New York State, which some of these regions here don't typically see severe weather this time of year. So this is definitely something we got to be watching here very closely. This could be a widespread severe weather event. Definitely something we got to be watching for very closely here, especially for a lot of these highly populated areas here as well. So this is definitely something we got to be watching here. And looking through the significant tornado parameters, you can see here pretty decent numbers here. It's given really the higher probability for tornadoes, or the most favorable environment for tornadoes. It's looking to be eastern North Carolina and eventually getting into southeastern Virginia as well. Even areas in the dark green here still has the tornado threat in there. Areas in this green here, not really tornado threat, but when you get into these dark greens here, you pretty much have a tornado threat. Really over a 1, you got tornado threat. Just to be basic there as well. Let's look into the energy helicity index. So this is the combination of helicity and CAPE. You can see here, it got some decent values here. You got as high as a 2 here as well. So definitely something we gotta be watching here as well. And I believe, if I'm correct here, the storm relative helicity is pretty high as well. So that's another ingredient for severe weather there as well. Those numbers are pretty high across these regions here as well. All right, let's take a look to those wind speeds here. And this is really for any areas that they're in the divergence zone, which I'll show you guys here, does have the chance for severe weather. And you can see here, we got a very large divergence zone right here, which includes the Carolinas, Virginia, up into Maryland, Delaware, even West Virginia, up into Pennsylvania and New Jersey. Here's what we got, a very large divergence zone. Typically when this happens here, this makes thunderstorms able to go up into the atmosphere. Now, if you're under something like this, like down in Georgia, it's a little bit more suppressed. There's now around in there. So really, big thunderstorms really can't develop, but with some setup like this here, with divergence here, thunderstorms will be able to easily develop into the atmosphere as well. So this is, again, definitely something we need to watch for. Here's what for some severe weather. But anyways, guys, this is all for you guys today. Hope you guys did enjoy this video. If you guys like this video, hit the like button. If you really do like my channel, hit the subscribe button. Hit the bell notification so you never miss an upload. If you guys have questions about this, you can put it in the comment section down below. I'll answer you guys questions. I'll see you guys in the next one. Goodbye.